Hey you guys, we are in section 5. We are going to look at proportions in triangles. So we have two objectives here. We want to be able to use the side splitter theorem to determine lengths of segments within a triangle, and we're going to use the triangle angle bisector theorem. So we have two theorems that we'll be using. Alright, so the first theorem is called the side splitter theorem. This theorem says that if a line is parallel to one side of a triangle, and it intersects the other two sides, then it divides those sides proportionally. So it says if line RS is parallel to line XY, so these are parallel as indicated by the arrows, then these sides XR and RQ is proportional to YS and SQ. Now you don't want to get this confused with the triangle midsegment theorem because it kind of does look like a midsegment, except for maybe it's not right in the middle, and therefore it's not a midsegment, even though one of the properties of midsegments was that it was parallel to the third side. Since we don't know where R and S are, we're not going to say it's a midsegment. So here we just have a side splitter theorem, and we have a segment RS that's parallel to this third side, XY. Alright, so it says what is the value of x in the diagram and what is the value of a? So what is the value of a would be for the u-try. For my example, I want to find the value of x. So using the side splitter theorem, I'm going to write the proportion x plus 1 over 12 is equal to x over 9. And then I'm just going to solve. So cross multiplying, when I multiply the means, I get 12x. And when I multiply the extremes, I get 9x plus 9. Bringing the 9x to the left side using subtraction, I'll get 3x equals 9. And then dividing by 3, x equals 3. Alright, so now you use the side splitter theorem to go ahead and solve for a. So you try. Before we look at the other theorem, we're going to look at this corollary. We have a corollary to the side splitter theorem. So this corollary says if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if line A is parallel to line B, is parallel to line C, these are all parallel to each other, then the segment AB is to BC as WX is to XY. So those segments are proportional on the transversals. So it's important that these lines are all parallel, and it's important that you're recognizing the segments made by the transversals. We're not looking at the segments made by the parallel lines. So just the segments intercepted on the transversals are proportional. So for example, it says 3 campsites are shown in the diagram. What is the length of site A along the river? So we see we have 3 or more parallel lines that are intersecting two transversals. So I know this segment is to 8 as 9 is to 7.2. And I want to find this segment right here. That's the length of site A along the river. The blue here is representing a river. So I'm going to put an X there. And I'm going to say just that. So x is to 8 as 9 is to 7.2. I'm going to cross multiply. I get 7.2x equals 9 times 8, so 72. And divide by 7.2, so x is equal to 10. So the length of site A along the river is 10, and we are in yards, so 10 yards. Alright, so you try. Here's your problem. It says, what is the length of site C along the road? Alright, and now we're going to look at the triangle angle bisector theorem. So the triangle angle bisector theorem says, if a ray bisects an angle of a triangle, so here's ray AD, and it's bisecting the angle CAB, this angle right here, and it indicates that by these little arcs showing that this is an angle bisector. Cut it in half. So if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So here is an angle bisector. We know now that this side CD is to DB as CA is to BA. So we can make this proportion. So here's an example. It says, what is the value of x in the diagram below? So I see I have a triangle, and this triangle has been split into two smaller triangles by this angle bisector. I know it's an angle bisector because of these arcs right here. So I can make the proportion 10 is to 18 as 12 is to x. And I can go ahead and I can solve again, cross multiplying. 10x is equal to 216. So x is going to be equal to 21.6. All right, so you try. It says, what is the value of y in the diagram below? Once you finish that problem, make sure that you took good notes, that you have down both theorems and the corollary. Make sure you have my examples as well as the you try problems. And that's it for this video. We are done with chapter 7. This is the last section. So make sure you rewind and you clear up any misconceptions, and we'll review this section in class next time I see you.